Biochar is more than just charcoal. It's a soil superpower. Produced by heating organic material like crop residues, wood chips, or nutshells in a low-oxygen environment, biochar transforms waste into a stable, carbon-rich substance that can last in soil for centuries. Unlike ordinary compost or burning, pyrolysis locks carbon away, creating a sponge-like structure that improves soil health. Picture this: a tiny network of pores in soil, silently holding water and nutrients, nurturing life below our feet. This is biochar at work, quiet, powerful, and enduring. From rice paddies in Southeast Asia to cornfields in the American Midwest, farmers are embracing biochar, witnessing healthier soils and higher crop yields. Rooted in ancient practices, yet validated by modern science, biochar holds a promising key to sustainable agriculture and climate mitigation. It's more than a tool. It's hope for our soil, our food, and our planet. Biochar's benefits are promising, but they're not guaranteed. When applied correctly, it can improve soil structure, boost water retention, and even enhance crop yields. In Ethiopia and Kenya, studies show maize and sorghum flourishing in biochar-treated soils, especially during harsh dry seasons. But here's the catch: biochar isn't a miracle. Its impact varies with soil type, feedstock, and how it's applied. Sandy soils respond differently than clay, and not all biochar is created equal. Some critics have even called it the snake oil of modern agriculture. Yet, the truth is more nuanced. Biochar works best as part of a holistic soil management approach, alongside composting, crop rotation, and sustainable irrigation. When used thoughtfully, it can become a quiet ally in restoring soils, nurturing crops, and building resilience against a changing climate. One of biochar's most exciting promises is its potential to fight climate change. By locking carbon in a stable form, biochar keeps greenhouse gases out of the atmosphere for hundreds, even thousands of years. Imagine the soil as a long-term carbon vault, quietly safeguarding our planet's future. Tune in an emotional moment. Across the globe, projects are proving this vision. In Australia, experimental farms are sequestering tons of CO2 using biochar made from crop residues. Scientists estimate that if biochar were adopted widely, it could capture billions of tons of carbon annually, enough to complement reforestation and other climate strategies. But the benefits don't stop there. Biochar also improves soil water retention and reduces the need for synthetic fertilizers, helping farms become more resilient to droughts and extreme weather. While it isn't a silver bullet for climate change, biochar is a powerful ally, a vital tool in the growing toolkit of regenerative farming and environment. Biochar turns waste into wealth. Agricultural residues, forestry scraps, and even urban green waste can be transformed into a valuable soil amendment. This is circular economy in action, reducing waste, creating value, and protecting our natural resources. Picture vineyards in California, where prunings once burned now become nutrient-rich biochar, enriching soils and cutting pollution. Across Queensland, sugarcane residues are repurposed, boosting crop resilience and opening new economic opportunities for farmers. Beyond improving soil, biochar production creates financial incentives through carbon credits, rewarding sustainable practices. By turning leftovers into long-term benefits, biochar shows how agriculture, environmental stewardship, and economic growth can work hand in hand. It's an innovation born from science, realized through practical action, and shaping a more sustainable future for our farms and our planet. Who's promoting biochar? A growing mix of NGOs, startups, and carbon credit markets. NGOs highlight its environmental benefits, startups push innovation and commercialization, while carbon markets emphasize climate potential. These voices have amplified biochar's profile. But not all claims are backed by rigorous evidence. Scalability, affordability, and accessibility remain questions. High-tech production facilities are expensive, and smallholder farmers may lack resources to adopt biochar widely. Carbon credit incentives can help, but regulatory frameworks are still catching up. Understanding who benefits and how is key to separating genuine impact from marketing hype. Biochar holds promise, but careful implementation, monitoring, and community engagement are essential for its success and credibility. Biochar isn't without risks. Its effectiveness varies depending on soil type, feedstock, and application method. Contamination risks exist if biomass contains heavy metals or chemicals. Energy use during production can offset carbon benefits if not carefully managed. Scientific skepticism and regulatory gaps remain. Researchers stress that biochar is a tool, not a panacea. Misapplied, it could lead to inconsistent results or economic losses. Awareness, quality control, and proper education are essential to ensuring biochar fulfills its potential sustainably. Understanding these limitations allows stakeholders to apply biochar responsibly, enhancing soil health, sequestering carbon, and supporting sustainable agriculture without falling for overhyped claims. The proof of biochar's potential lies in real-world impact. In California, vineyards using biochar report improved soil structure and healthier vines, while crop yields increase. Queensland sugarcane farmers note enhanced water retention and nutrient efficiency, reducing fertilizer needs. Before and after soil tests reveal higher organic matter, better water holding capacity, and improved microbial activity. Farmer testimonials highlight resilience during droughts and economic benefits from carbon credits. These cases demonstrate that, when used thoughtfully, biochar is more than theory. It's a transformative tool for sustainable agriculture. From smallholder farms to commercial operations, biochar's integration into farming practices offers hope for healthier soils, more resilient crops, and meaningful climate action.